Well, we pick up here with the mission patch for STS-42. Here we are in the suit-up room. This is myself, Steve, Bill, Norm, Roberta, Dave, and last but not least, of course, Ulf. All of us going through the suit-up in parallel. Here we are walking out of the O&C building. We had a beautiful day to go launch, and we certainly took advantage of that. We were really ready to go fly.
Well, I get to talk through Ascent, and I guess after being assigned to the flight for 2 or 3 years, as some of the crew members were, and after sitting on the pad for several hours, we were certainly glad to get down to this part of the count and finally lift off. I guess there are no amount of words that can really describe this phase of the flight. The vibration and the raw power that's being exerted on a vehicle during this first 2 minutes of the flight is truly awesome. I guess we all felt well prepared, but the view that I was getting at the right side of the vehicle during ascent was truly spectacular, looking out on the East Coast. Booster separation, as you see in the film right now, is something like an automobile accident. I guess I was a little bit unprepared for that. There's an awful lot going on, big bright flash of fire across the windshield there, and like everybody else on the ground, I guess we were glad to get the boosters gone and be on our way uphill with the main engines. Let me pass it over to Mr. Bill to talk about the tank.
Well, you see the tank floating by there. It was a really terrific job of photography by Norm and Dave, who managed to get the camera all put together and up on the overhead windows. It's a view of what we had out the window as soon as we got the payload bay doors open. You can see the IML patch on one side and the International Space Lab patch on the other.
Now, the Space Lab ingress, at about 3 hours into the flight, Norm and Bobby headed on back into the lab after opening the hatches and did the initial Space Lab activation. You see Norm and Bobby and then Mr. Bill floating back into the lab for the initial power-up of the lab and the initial activation of various experiments. There was an awful lot of logistics going on. Here's Norm is opening up the vents in the panel in the forward part of the module. But we had 11 lockers worth of late access materials that we had to transport back to the lab during the early part of the flight.
Well, Redshift, Bill, Ulf, and I came on about 9 hours into the mission after trying to take a nap of about 6 hours right after liftoff, which is pretty hard. I was back there working the cells experiment. I spent about 3 hours on that day, day one, working cells, while Ulf was in the back setting up the microgravity vestibular investigation experiment, the chair. Another experiment that we performed was a sled experiment. The space adaptation syndrome experiments were a suite of 7 Canadian experiments that looked at various effects, microgravity on human physiology. The sled had to be rotated twice, once for the Z direction, once for the X direction, and it investigated the effects of the otolith and 0G on vestibular responses. Quite a fun experiment to work with. We were getting a series of shocks, electric shocks, during that time.
I think everyone who's had any interest in the mission at all is familiar by now with, as Dave told you, the microgravity vestibular investigation, or MVI chair, that you see here. Every one of the payload crew, all 4 of us, rode the chair at least a couple times during the course of the mission. You can see the eye response there. The idea is that each of the semicircular canals, or each of the axes, 3 axes, can be investigated independently. You can place this chair in different positions. You saw it initially in the yaw position. Here it is in the pitch position, and it actually will induce then in the subject pitch motion. And I must say that even though this was 0G and we'd always imagined that it wouldn't make much difference on the orientation of the chair in 0G, it still, to me, seemed like it was a chair on its side here in the pitch position. So you've seen the yaw and the pitch. I'm not sure if we have the roll position, but it also would go into the roll position. And you can see us, I'm assisting Roberta to get into the chair, and after she's in the chair, then I'll go over to the computer, which is off to the right there and a little out of view, and actually command the runs in sequence. As research tool for basic research into the vestibular and the relationship between the vestibular and the optic system. It's an excellent tool. And to really separate out the influence of otolith, which is a linear detector, a linear acceleration detector, and the semicircular canals, which detect angular motions, you almost have to take something like this to 0G. And you see here now a sinusoidal run in the pitch plane. And this, we thought we'd include this just because it shows you that it's very easy to change the chair from position to position. It would be sort of an operational hit to have folks get out of that chair and reposition it. In 0G, that's not necessary. And so after we finished the pitch run, then Roberta just lifts the whole chair and places it in the yaw position.
And here a guy to go over to the glove box and do some experiments on BioRAC. This is the facility that the European experiments were set up to look at certain aspects of microgravity and cosmic radiation and their interaction on various types of tissue, including bacteria, fruit flies. We had experiments looking at bone and cells to see how cartilage and bone are affected by that type of environment. The glove box itself had a cooler refrigerator, cooler freezer, a freezer on top, a cooler, and then 3 incubators. You can see me going into the cooler here. Previously, I was going into the incubator where you could see centrifuges moving around. We had over 160 of these black containers in which we performed the experiments. Most of the experiments were performed inside the glove box, which you can see in front of me. This is one of the BioRAC experiments that has come out of those black containers. They're actually seeds that we're looking at how the roots were affected by microgravity and also by putting them on a centrifuge and how they change. I'm taking the individual specimens and putting them into a photo box. There's a camera inside this box which fired off photographs at specific times. And here we can see the redshift as well. They would carry on experiments when we were finished.
We had 2 exercise devices on this flight. We had a bicycle ergometer, which you see Steve exercising on right now. The idea of these 2 exercise devices was to minimize the impact on the microgravity environment. You've probably seen the treadmill in use before, and the pounding through the orbiter structure of the treadmill is something that disturbs the microgravity environment. So we're looking at alternative exercise devices. One of the other things for a laboratory flight, you need some kind of eye wash protection in case you have a toxic agent or something loose in the lab. And this is a prototype eye wash device. It does wash your eyes out pretty effectively, among other things. The payload crew was too valuable to experiment on, by the way.
Well, I guess we're real valuable here. We've got the pilot, and we're trying to refresh him on his scientific knowledge here. This is really a transcranial Doppler is the name of this particular experiment I'm doing in the mid-deck, and we're really looking at blood flow disturbances or blood flow changes in microgravity using ultrasound. And now we're going to go back into the space lab. This is a nice view going down through the tunnel. And as you come down through it, you can see that there's not a lot of room if you have a whole bunch of people going back and forth. And I made the mistake of coming down at this precise point when Steve was coming up with the camera. But it was very easy to backtrack. In fact, it was kind of fun to do a somersault back into the lab where you can see everybody is hard at work. Of course, I've got a drink bag that I'm flying around with.
One of the things we told them is we needed a traffic light so that you could tell when it was clear to go down the tunnel or not.
Bill and I are working here on the IMAX camera. We had the camera, which weighed about 100 pounds or so in 1G, much easier to manipulate in 0G. We had 13 rolls of film, and our objective was to shoot 30-plus interior scenes and 3 rolls of exterior scenes, and we got most of that done, and the initial impression from the IMAX folks is that material turned out to be very good. We hope to see that here on Wednesday night for the first time. The scenes were shot in preparation for their next movie, which will be put together with some film that was shot on STS-31. Frequent flights. I guess the preliminary title for that movie is Destiny in Space.
Well, here's the first material science experiment It is the TGS experiment. We had all kinds of single crystal experiment to be grown under zero gravity. And interestingly enough, we did not have one that was grown from the melt. Most of them were grown from solution, like that one. You see still some raw material, crystallite, sitting there in the cell. That is triclosan sulfate, or whatever you pronounce it. And here's another material. That is ammonium chloride, and it is called CAST. That is a model experiment to understand the growth of dendrites. You see these needles. Dendros is a Greek word, means tree, and many metals grow exactly that way if they solidify from the melt. Here is another interesting material, mercury iodide, which is a promising detector material for X-ray and gamma-ray detectors. That experiment had been done before on Spacelab 3. We grew crystal about twice as big as that one grown on Spacelab 3. We had several hundreds different proteins that were also grown from solution, and this one is called the cryostat. In this case, it was grown by liquid diffusion.
Now we have Ulf showing his talents over on the life science side. He's planting oat seeds in an experiment, a part of the gravitational plant physiology set called GPPF. This particular subset is called GTHRES, looking at the effects of gravity on plants, and he's actually doing in-flight planting and also assessing the height of the seeds. Right now I'm over here at the GPPF facility. There's a keypad on there, and we had to put in various types of data to organize the centrifuges inside the facility. And this shot's over the glove box. This was the plant experiment again, but we're utilizing the BioRag glove box to contain the fixative inside the bags. The glove box was very handy for doing this type of experimentation. We had small gloves on board, which I used, and medium-sized gloves for everyone else. And you can see stuff can float freely around in there if you don't have it tied down, and quite often we had to go in and put double-sided tape or loops of tape inside the glove box. When we finished the individual experiments, we could take them out through the glove box door, close it up, which was real important, otherwise things would float out, and then go back and put things back where they belonged.
Well, this is a refrigerator called the Leslie freezer. We used it to put biological specimens in it in order to preserve and conserve them for post-flight analysis. It was also, to some extent, an engineering test. That particular refrigerator may fly again on later flights. Here you see a general view of the Spacelab interior. As an ESA man, I take the liberty to remind everyone that that is the ESA contribution to the shuttle program, and whenever it has flown, it worked out without major problems. So I think it's a pretty powerful instrument for all kinds of scientific investigations. As you can see, it's pretty wide and nice.
Well, I think you get the flavor that we were pretty busy. When we did look outside, we were often treated to some pretty dramatic views of snow and ice. Here's Lake Manickawagan in northern Canada. Here we are coming across the northern sea of Japan, across Sakhalin Island. That's the landmass coming into view beneath the tail. Now as we continue on eastward, we'll pick up the Sea of Okhotsk, and you'll see some very dramatic ice flows forming here just off the eastern coast of Sakhalin. It was primarily daytime in the northern hemisphere, so our views were at the northern latitudes, and this is the sort of inhospitable sort of territory that we were generally viewing, but the views were very dramatic.
Okay, here we are around Fillmore, Utah on Descending Pass. You can see the United States is pretty spectacular for the mountain terrain that we have as well. Crossing over the Wasatch Plateau and coming into the lower left corner here pretty soon, you'll start to pick up the Green River, Colorado River flowing into Lake Powell and the Canyonlands National Park. You see Lake Powell coming in. And as the color of the terrain changes, you'll be seeing Monument Valley, Utah. And finally, we're coming up on the Four Corners, which is kind of a unique part of the United States where Utah, Colorado, Arizona, and New Mexico all join in one point. I'm afraid the pictures in the movies just can't do justice to the view out the window.
Now here we are in the last part of the flight. We had an awful lot of sunsets. We were flying right along the Terminator for most of the flight.
Well, it took a lot of work to get the module cleaned up after all the things that we had unstowed. As you saw, the picture that Ulf was talking to showed all the various pieces of equipment that we had out, from lights to payload equipment, experiments. And it took a lot of work to perform that metamorphosis to actually deactivate the payload. Coming down the tunnel for the last time was kind of nostalgic. Kind of like saying goodbye to an old friend, the Space Lab that performed flawlessly throughout the whole mission. And finally, we go through the hatch and close it up into the tunnel adapter. It's amazing, 50% of your volume is taken away when you close that hatch, and suddenly things for 7 people become much more crowded, as we found out in deorbit prep.
Well, we were lucky enough to get an extra day on orbit, an 8th day, thanks to some ingenious power saving by the folks on the ground. But all good things, I guess, need to come to an end. And here we are on the flight deck, some camcorder video of Bill. We tried to drink as much fluid as we could prior to re-entry to help us once we got on the ground. It's a view out my window there, looking at the horizon. A view out the overhead windows during re-entry as the hot gases pass over the overhead windows. They tend to flash like that. Some rather dramatic video. It was truly a beautiful sight re-entering, and a spectacular view of the West Coast. It was just a perfect day for an entry and landing at Edwards Air Force Base.
This clip picks up with the orbiter on final. It was absolutely a perfect day for landing. We should all have the good fortune to return on such a pretty day. Landing the orbiter turned out to be something we were exceptionally well prepared for. We had some outstanding training tools, namely the shuttle training aircraft, which really does an excellent job of simulating the approach and landing handling characteristics of the orbiter. We're landing at Edwards Air Force Base because we had extensive post-flight baseline data collection to augment the physiological data that we acquired on orbit. There's touchdown on Edwards runway 22. And derotation. Best part of a space flight, particularly one that you're really well pleased with the results, is when you actually get to come home. We sure enjoyed our time in orbit, but it's always the best part is arrival back on Earth.